All right, with part 2 of our infectious agents, I've got another bacteria that I want to mention, and that's going to be Pseudomonas aeruginosa. All right, Pseudomonas aeruginosa, very commonly associated with respiratory infections. All right, if you go to the doctor and the doctor asks you what color is your snot, right, and you may tell them it looks kind of green or a little green fluorescent, that is a potential indication of Pseudomonas aeruginosa. Because Pseudomonas aeruginosa, it's a gram-negative bacteria, all right, which means it's not going to respond to an antibiotic like penicillin that targets the cell wall of a gram-positive bacteria, all right. The Pseudomonas aeruginosa, the green color comes from a pigment that that particular bacteria makes. It makes kind of a green pigment. If you are taking the CNM micro lab, Pseudomonas aeruginosa is one of the bacteria that you work with, and if you look at the plate, it's going to have kind of a green cast to it. You'll see this towards the end of micro lab when we do some testing of different antibiotics, and it's going to be a little bit scary what you're going to see as far as antibiotics and Pseudomonas. That's why the doctor or the nurse practitioner or the nurse wants to know what color your snot is, because that can give a potential indication of what infection there is. Although it doesn't guarantee it, there are other bacteria that make pigments as well, okay? But in terms of that, it's typically respiratory, although if you have or deal with severe burn patients, Pseudomonas aeruginosa a lot of times will colonize burns and that open wound associated with a burn, okay? One that I mentioned briefly when we were talking about biofilms was Streptococcus mutans. Streptococcus mutans is a gram-positive bacteria. This is going to be primarily the bacteria associated with dental plaque. And in terms of that, that's going to be the glycocalyx that's going to be responsible for allowing that bacteria to sit down and attach on the tooth surface. All right, that sugar that that's released kind of acts like a glue. All right. In terms of that, Pseudomonas Streptococcus mutans. Another one I want you to know is going to be Bacillus anthracis. Okay, this is going to be a gram-positive bacteria. This is the bacteria that causes anthrax. So if you remember from when 9/11 happened, there was shortly after that a number of scares with anthrax as well, with people putting it in the mail. The way that works, Bacillus anthracis forms an endospore, okay? So in terms of that, that endospore allows the survival of that particular bacteria over long periods of time. So it could be put into a letter because it's a spore form, and when the person opens the letter, releases the spores, the person inhales the spores, and they could contract anthrax. All right. You'll notice one of the slides I have in this week's lesson is on dose. Okay. So in terms of that, there's going to be an ID 50. This is going to be the dose that will infect 50% of people who are exposed to it, all right? And in terms of that, the portal of entry can make a difference in that ID 50 number, okay? If we're talking about Bacillus anthracis in getting into a wound, into the skin, so if you step on something or cut yourself, it only takes maybe 10, 20, maybe more, maybe 100 spores for the person to get sick, for the infection to take hold within the skin, okay? But in terms of Bacillus anthracis and inhalation going in through the respiratory system, you need 10 to 20,000 spores in order to get infection. So in terms of that, the portal of entry can make a difference as far as the infectious dose as well. So in order for a particular bacteria to be pathogenic, you have to have a certain number of bacteria before the person gets sick, okay? And that's that infectious dose, okay? So in terms of that, with anthrax, skin, you don't need very many spores at all. Inhalation, you need many more spores. And if you're talking about ingesting it, if you take it in through the digestive system, you're looking at needing maybe 500,000 of those bacterial endospores in order for the disease or the pathogen to take hold, okay? In terms of that, in general, digestive system requires usually a higher infectious dose, all right? There are always going to be exceptions out there with various bacteria, but the benefit of your digestive system is the normal flora that you have associated with your digestive system. That normal flora kind of outcompetes something new that comes in, all right? So that something new that comes in, you've got to have a whole lot of it in order to knock down or get by your normal flora, okay? So keep in mind the route or the portal of entry can make a difference in how much or how many of the bacteria you need to be exposed to before you get sick, okay? So keep that in mind. If you have any questions, please let me know.